Alright, so now we're going to begin to discuss curve sketching, which is a little bit more of a daunting unit, but it's not that bad when you break it down. So on a quiz or an exam, it kind of takes a long time to do a curve sketching problem, so you might only be asked one problem per quiz or exam. And the prompt that you might be given might be very brief, something like this, where you're just given your f of x and then you're told to sketch the curve. And you have to know to compile all this information, some about the base function, some about the first derivative, and some about the second derivative. And all that stuff is going to help you graph your function. And in fact, you'll actually be asked to kind of explicitly state all of these things. You're going to want to just put it down on the paper. So let's start with our f of x. This is stuff that we need to identify about our base function. So the first thing we're going to need to do is we're going to need to identify the domain. And the nice thing about this function is because it's not a super complicated example, it's a polynomial, and polynomials are going to be defined everywhere. So their domain is going to be negative infinity to positive infinity. These are functions that don't have any division. There's no numerators or denominators. There's no logarithms. There's no x's in the exponents. There's no craziness going on. It's just nice and simple. Maybe you have a minus, a coefficient, an x to a power, something like that. But generally speaking, there's not too much going on here. So in these type of functions, you have your domain is all real numbers, also known as negative infinity to infinity. Your asymptotes, well, you don't have any asymptotes. You don't have any discontinuities. And you do have intercepts, though. You do have intercepts. And intercepts are actually one of the most important things when it comes to curve sketching, because they're really the anchor points of your graph. So first, let's start with our x-intercepts. Our x-intercepts is where our x equals 0. So we're looking to evaluate f of 0 here. So we're going to our f of x all the way up here, and we're plugging 0 for everywhere we see an x. So that's 0 to the 4 minus 6 times 0 squared. That should equal 0, right? So f of 0 equals 0. So we have an x-intercept at 0, 0. Okay, cool. Now let's find our y-intercepts. So our y-intercepts is where our f of x equals 0. So we're taking our f of x here, up here, and we're setting it equal to 0. So we got x to the 4 minus 6x squared equals 0. And so we can factor out that x squared. We get x squared minus 6 equals 0. So we can see that we have a 0, right? When this term out front, when this term equals 0, our whole thing equals 0. So 1, 0 is x equals 0. So that's 0, 0, which makes sense, right? Because we found 0, 0 was a point over here for our x-intercept. That's the origin, right? 0, 0 is the origin. So, and the origin is not only an x-intercept, but also a y-intercept. So it makes sense that we also found that. But also, if this inside equals 0, then our whole thing equals 0. So we could say x squared minus 6, when that equals 0, we're also going to have an x-intercept. Or sorry, a y-intercept. So x squared minus 6 is going to be equal to, or x squared equals 6. So we got x equals the square root of 6, plus or minus the square root of 6. And the plus or minus is important. And I'm going to just, because now we have 3 x-intercepts. We have the origin, we have minus 6, and we have positive 6. And so these are going to give us points. So our x are, we're going to have negative square root 6, comma 0, and we're going to have square root 6, comma 0. So now we've got our domain, we've got our asymptotes, we've got our discontinuities, and we've got our intercepts. Great. So now we're going to move on to our first derivative. So let's go ahead and let's get our f of x. Okay, so now we want to derive this, right? which is going to be 4x cubed minus 12x. So now we want to set this equal to 0. And this is going to help us make a sign chart. So we can factor our 4x out of here, which will leave us with x squared minus 3. That equals 0. So we could see we have one of our potential critical points is going to be x equals 0, right? Because when this outer term is equal to 0, the whole thing is going to be equal to 0. Okay, but when this inside term equals 0, then we also have our whole thing equals 0. So whenever x squared minus 3 equals 0, the whole thing equals 0. So x squared equals 3. So x equals plus or minus the square root of 3. So now we have x equals 0 and x equals plus or minus the square root of 3. So this is going to let us make our sign chart. Let's make it over here. We got negative square root 3, we got 0, and we got square root 3, positive square root 3. So now we're going to plug in one of these into here. So when we plug in over here, call it negative 5. Let's plug in negative 5. This term is going to be negative, but this term is going to be positive, right? Because this will become 5 squared, which is 25. 25 minus 3 is 22. 22 is positive, so we get a negative times a positive, so we get a negative here. If we plug in something between negative square root 3 and 0, so we could plug in negative 1, this will be negative, and this will be negative, right? Because that'll be negative 1 squared, which will be 1 minus 3, which should be negative 2. So you got a negative times a negative, which is going to give you a positive. And here, let's say we plug in 1. This is going to be a positive. And then 1 minus 3 is equal to negative 2. So we're going to have a negative inside here, which is a negative times a positive is a negative, right? And then if we plug in something to the right of square root 3, say we plug in positive 5, we get a positive out here, and then we get 25 minus 3 equals 22, which is positive. So we get a positive times a positive, and that's going to give us a positive. So now we can say, we can set our intervals of increasing and decreasing now, right? Wherever our first derivative is positive, we are increasing, and wherever our first derivative is negative, we are decreasing. So from negative square root 3 to 0, we're increasing. And then also from square root 3 to infinity, we are increasing. And then decreasing, well, that's everywhere where we're not increasing, right? So from negative infinity all the way up to negative square root 3, we are decreasing. And then all the way from 0 all the way up to square root 3, we are decreasing. This is our intervals of increasing and decreasing. We're all done there. So now we just need to pick out our maxes and mins, which we've really already done the work for. When we go from decreasing to increasing, we have a minimum. And when we go from increasing to decreasing, we have a max. And then if we go from decreasing to increasing, we have a min, etc. So we have a min at x equals negative square root 3, and we have a max at, or sorry, we have two mins at x equals negative 3, or sorry, x equals negative square root 3 and x equals positive square root 3. And then we have a max at x equals 0. All right, great. I would also note that on a quiz or an exam, you will probably be expected to plug these back into the original function. So you would take your negative square root 3 and you would plug it back into your original function. Keep in mind, we are not talking about the derivative. You are not plugging it back into the first derivative. You're plugging it back into the normal function. Just for the sake of time, we will not be doing that. But on the test, you'd probably be asked to actually find those. So just remember, you plug it back into the base function, not the first derivative. Okay, so now we can move on to our second derivative. So we already took our first derivative. So now in order to find our second derivative, we just take the derivative of that, and we get 12x squared minus 12. And so this will factor out nice, because again, we want to set this equal to 0 too, because we want to make a sign chart for this as well. So let's just factor out that 12. So we can see that this equals 0 when x squared minus 1 equals 0. So that's when x equals 1. And then, so then x equals plus or minus the square root of 1. So x is going to be equal to plus or minus 1. That's when we're going to have our zeros. So let's make our sign chart, kind of like pretty much exactly what we did for the first derivative. That we take something just to the left of -1, call it -2. This becomes positive, right? Because then we would have -2 squared is 4, minus 1 is positive 3. So we are going to be positive here. Then, if we plug in something between -1 and 0, -1 and 1, say we plug in 0, we get 0 minus 1, which is -1. So that's a negative. So then our whole thing is negative. And if we plug in something to the right of 1, say we plug in 2, then in here we're going to get 4 minus 1, which is going to be 3, and that's positive. So that's how we figure out our intervals of concave up and concave down. And on that note, let's write that. Remember, when we are concave up, our second derivative is positive. We are concave up when our second derivative is positive. I don't know why I wrote 2 there. From -infinity to -1, we are concave up because our second derivative is positive. And then from 1 to positive infinity, we are concave up because our second derivative is also positive. And then we are concave down everywhere we are not concave up, which is going to be on the interval, the middle here, -1 to 1. So now we have pretty much all the information we need about our second derivative, as well as pretty much all the information we need about our first derivative. So now we're ready to start sketching. And so let's draw our grid. Always start by drawing your grid. And then I'm going to start with my asymptotes. So, sorry, not asymptotes, our intercepts. So we know we had 3 intercepts. We had 1 here at the origin. We had 1 here at negative square root of x. And we had 1 here at positive square root of x. So we know these are 3 points that we already guarantee are going to be on our graph. So, okay, we got those. So now, where are our maxes? Our maxes would be, and our mins. Our maxes and our mins would be another great place to fill in. So we're going to have a min at negative square root 3 and square root 3. So square root 3, actually let's just look at our intervals of increasing and decreasing. So if from square root 3, so let's plot that on our graph actually. So negative square root 3 is going to be here. Okay. So what do we have at negative square root 3? We have a min, right? We have a min. We are increasing from -3 to 0. And then, do we have an inflection point? Yes, we do. I forgot to put this in here. An inflection point is where we change concavity. So we go from either positive to negative or negative to positive. So, and we have 2 of those, right? We have 1, we go from positive to negative here. We go from negative to positive here. So that's going to be -1 and 1. Let's see, is there anything else? we got our domain, we got our asymptotes, we got our discontinuities, we got our intercepts, we got our intervals of concave up and concave down, we got our inflection points, we got our intervals of increase, decrease. And then this is going to be what our final graph looks like.